In this video, we are going to calculate V0, also the open circuit resistance about V0, and the closed circuit resistance about V0. To begin, we will calculate V0 with our voltage and current source. So below we have the equation. I'm going to point out to you where all these numbers come from. First of all, our 5 volts is up here. Secondly, we have 3 kiloohms and 6 kiloohms in series, and we're going to use our voltage divider equation with those on top. And underneath, we are going to have the entire resistance in series. Okay, moving on to our next term, we have 1 milliamp right here. And we can use our current divider equation. We want to know the current through the branch with the two 6 kiloohm resistors. So what we do, if we want to know the current through here, is we put this 3 kiloohm resistor on top. Then we put the total value of all the resistors on the bottom, just like before. And now, for the current source's contribution to V0, we are going to finally take the value of current going through here and subtract it from the value of current going through there. When we multiply that current by the resistance using Ohm's law, that will give us our voltage. Now keep in mind, this is our open circuit voltage. Our 2 kiloohm resistor has been omitted. Next, we will calculate our open circuit equivalent resistance. I'll show you where these numbers come from. So our equivalent resistance has this 3K and 6K resistors in parallel with this 6K resistor. So we're just going to take them in parallel. These two are in series, 3K and 6K, which gives us this 9K right there. And then that is in parallel with our 6K. Then underneath, we take the total value of all the resistors together. That gives us 54 mega divided by 15 kilo. That gives us 3.6 kiloohms for our open circuit equivalent resistance. Finally, we will calculate our closed circuit equivalent resistance, and I'll show you where all these numbers come from. It's essentially the same as the last problem, except we have one extra resistor that's in parallel with the rest. Right here, this 2 kiloohm resistor, that is in parallel with this 3 kiloohm plus 6 kiloohm combination, which is in parallel with this 6 kiloohm combination. So first, I calculate the 2 kiloohm resistor in parallel with the 9 kiloohm resistor, giving us 1.64 kiloohms. And we take that in parallel with our 6K resistor, which is right here. And that gives us 1.28 kiloohms closed circuit equivalent resistance.